Welcome friends, let me share the concepts with you behind adding these two rational expressions. Take a look, we have x squared plus 7x plus 12 and here we have x plus 4. What stands out, I would say, is that x squared plus 7x plus 12 is definitely not the same as x plus 4. These are very different expressions, so you have to make them the same. What we have in the bottom is a trinomial that I set up basically so it can be factored. So let's do that as a first step. Actually, it's done aside then. We're going to factor x squared plus 7x plus 12. So the question to be answered with this kind of factorization is the following. A number times some other number has to equal to 12. And then a number plus that same other number has to equal to 7. So really you should pause the video and see whether you can find these two numbers. They're not too hard to find here. But the result will be that you get x plus 4 and then x plus 3. The reason is 4 times 3 or 3 times 4, either way you get 12, and then 4 plus 3 or 3 plus 4 is 7. That's why. In other words, here you may want to complete this little chart for yourself. Like this is 4, this is 3, and this is 4, and this is also then 3 right here in this position, see? So that gives us what we need, those numbers. So now let's come back over here. We're going to have 1 over x plus 4 and then x plus 3, and we're going to add to it 1 over x plus 4. Now compare the denominators carefully. X plus 4 in this position right here is already present in this position right here, so that's not an issue. Those parts are already the same. This x plus 3 that you see here, for example, in blue is missing from the second fraction. To add fractions, whether they have only numbers in them or they have expressions and variables, you need to have the same looking bottom in both cases. So you're adding pieces essentially of equal size. But so here to do that, I'm going to say x plus 3. Now, once I multiply x plus 4 by x plus 3, I cannot just randomly do that because I'm changing the fraction. So I have to compensate appropriately by multiplying by x plus 3 also in the numerator this way. Now remember that x plus 3 divided by x plus 3 is a form of the number 1. That is why that is allowed. And then you carry it out from here. So it's going to be 1 divided by that x plus 4 and then x plus 3 plus distribute this one over to the x and the 3 individually. So it's going to be 1x, which is just x, and 1 times 3, which is 3. So you end up with x plus 3 in the top divided by x plus 4 times x plus 3 in the bottom. Now that the bottoms are the same, you can just add up the numerators. So you can say, in other words, 1 plus x plus 3 at first, and then place that all over just that same one bottom, x plus 4, and then x plus 3. And then you work through this. The last step is you can say 1 plus 3, for example, is 4, so you can say x plus 4, or 4 plus x, makes no difference, and then x plus 4, and then x plus 3. And now, take a look. This actually is the same as this, isn't it? So that means you can cross them off, but you gotta remember something, that when you're crossing this off, imagine it's inside of parentheses and it's multiplying the number 1. The common mistake here is to basically cross off x plus 4 and x plus 4 and not leave anything in the numerator, and just end up, for example, like with the expression x plus 3, which is not right. So what's left over in the numerator is the 1 that I've indicated there explicitly. In other words, what you have at the very end is 1 over x plus 3, and then this would be considered the answer. So please leave a like, please subscribe. Thank you so much for watching. I will see you in another video.